Ever wonder why during an eclipse, animals behave unusually, or why electronic devices sometimes malfunction? Welcome to Smoking Conversations W/Sakina-Ra, as we explain how it's a celestial story of magnetic fields. Our sun and moon, these luminous bodies in the cosmos, are not just silent spectators. They exert invisible forces that subtly shape our world, and during an eclipse, these forces come into play in the most intriguing ways. So, let's dive into the fascinating world of celestial magnetic fields and their impact during an eclipse. The sun, our very own star, is more than just a giant ball of hot gas. It's an immense dynamo, a cosmic powerhouse that generates a magnetic field so incredible it extends far beyond its visible surface. This magnetic field is not a stagnant entity. It's a dynamic, ever-changing force, born from the sun's internal movements. Deep within the sun's core, nuclear fusion churns out an intense heat that creates convection currents. These currents carry heat from the sun's core to its surface, in a process akin to boiling soup. But how does this create a magnetic field, you might ask? The answer lies in the sun's rotation. The sun doesn't spin uniformly like a solid sphere. Instead, it exhibits differential rotation, with its equator spinning faster than its poles. This churns the sun's plasma in a unique way, twisting and winding up its magnetic field lines. This process is known as the dynamo effect. It's like a giant cosmic generator, continually creating and recreating the sun's magnetic field. This dynamo effect gives the sun's magnetic field its basic structure, a dipolar field similar to Earth's, but with a twist. The sun's magnetic field isn't simply a north and south pole, like a bar magnet. It's far more complex. The field lines are wound up and twisted, forming loops that extend outwards from the sun's surface. These loops are the birthplaces of sunspots, solar flares, and coronal mass ejections, phenomena that can have significant impacts on our planet. But the sun's magnetic field isn't just about these fiery displays. It's also a protective bubble, shielding the solar system from cosmic radiation. It forms a vast, invisible shield, known as the heliosphere, which extends far beyond the furthest planet in our solar system. The sun's magnetic field, thus, is a complex and dynamic force that plays a significant role in solar activities. Its effects reach far beyond the sun's surface, shaping the very nature of our solar system and influencing life on Earth in myriad ways. Now let's shift our gaze slightly to the moon, our closest celestial neighbor. Unlike the sun and Earth, the moon's magnetic field is a tale of a force that once was, a faded echo of a time when our lunar companion was geologically alive. To understand the moon's magnetic field, we need to journey back in time, some 4 billion years ago. Back then, the moon was a hotbed of volcanic activity, with a molten core just like our Earth. This churning molten core created a dynamo effect, generating a strong magnetic field. But as the eons passed, the moon cooled, its core solidified, and the dynamo effect ceased. The once powerful magnetic field faded, leaving behind a weak remnant field that we detect today. Now you might be thinking, how does the moon's weak magnetic field compare to Earth's? Well, let's put things into perspective. The strength of Earth's magnetic field is around 50,000 nanoteslas. In contrast, the moon's magnetic field is a mere 1 to 2 nanoteslas. That's a difference of several magnitudes. So, why should we care about this weak, faded force? This seemingly insignificant magnetic field holds significant clues about the moon's past. By studying it, we can understand how the moon evolved and why it's so different from Earth. It also affects the way the moon interacts with the solar wind, the stream of charged particles emitted by the sun. During a solar eclipse, when the moon blocks the sun, this weak lunar magnetic field interacts with Earth's stronger field in fascinating ways. It can influence the path of solar particles, creating unique effects that scientists are still trying to fully understand. Despite its weakness, the moon's magnetic field holds clues to its past and influences phenomena during an eclipse. As we continue to explore the mysteries of our solar system, this faded force serves as a reminder of the moon's fiery past and its ongoing role in shaping our celestial experiences. An eclipse is more than just a spectacular celestial event, it's a dance of shadows. Now you may be wondering, what exactly is an eclipse? Simply put, an eclipse is an astronomical event that occurs when one celestial body, like a planet or a moon, moves into the shadow of another celestial body. Eclipses can be of two types, solar and lunar. During a solar eclipse, the moon passes between the Earth and the Sun, casting a shadow on a portion of the Earth. Conversely, during a lunar eclipse, it's the Earth that comes between the Sun and the Moon, resulting in the Earth's shadow falling on the Moon, giving it a reddish hue. But why do these celestial dances occur? It's all down to the alignment. Solar and lunar eclipses happen when the Sun, the Earth, and the Moon align in a straight line or nearly straight line. This alignment is also known as syzygy, a term that's as fascinating as the event it describes. But it's not just about shadows and alignments. There's a magnetic aspect to this celestial spectacle as well. The Sun and the Moon both have their own magnetic fields. The Sun's magnetic field, being much stronger, extends far into space, while the Moon's magnetic field is weaker and more localized. During an eclipse, the magnetic fields of the Sun and Moon interact in ways that can have some interesting effects. And that's the enigma we'll dive into in our next scene. Stay tuned. So what happens to the magnetic fields of the Sun and Moon during an eclipse? Now that's a question that has intrigued many minds. Let's delve into the celestial realm to uncover this mystery. During an eclipse, whether solar or lunar, the Sun, Moon, and Earth align in a straight line. This alignment, in addition to creating a visual spectacle, causes a unique interaction between the magnetic fields of the Sun and the Moon. The Sun, a giant dynamo, possesses a powerful magnetic field that extends far into space, reaching beyond the furthest planets in our solar system. This magnetic field is constantly in motion and fluctuates in intensity, largely driven by the Sun's rotation and the movement of plasma within its core. On the other hand, the Moon's magnetic field is quite different. It's faint, almost negligible compared to the Sun's. The Moon once had a stronger magnetic field, but over billions of years it has faded significantly. When an eclipse occurs, the Moon comes between the Sun and Earth during a solar eclipse, or the Earth comes between the Sun and Moon during a lunar eclipse. This alignment causes the magnetic fields of these celestial bodies to interact in a unique way. The Moon, despite its weak magnetic field, acts as a shield during a solar eclipse, temporarily blocking the Sun's intense magnetic field from reaching Earth. This results in a slight decrease in the strength of the magnetic field that we experience on Earth, a phenomenon often referred to as the Eclipse Effect. During a lunar eclipse, however, the Earth's magnetic field shields the Moon from the Sun's magnetic field. This interaction doesn't have a noticeable effect on Earth, but it does create a fascinating spectacle in the sky. These shifts in magnetic fields, subtle as they may be, can have interesting effects. Scientists have observed changes in the Earth's ionosphere, the layer of the Earth's atmosphere that's filled with charged particles during an eclipse. This can impact radio wave propagation, potentially affecting communication systems. Additionally, research suggests that these magnetic field changes might influence animal behavior. Some animals seem to react to the eclipse, showing signs of confusion or changes in activity. However, more research is needed to fully understand these effects. So while the eclipse is a breathtaking sight to behold, it's also a complex celestial event involving a dance of magnetic fields. And even though we may not feel these magnetic changes, they're happening right over our heads, subtly influencing our planet and perhaps even the creatures living on it. The effects of these celestial magnetic fields during an eclipse are subtle, yet significant. So next time you're lucky enough to witness an eclipse, remember, there's more than meets the eye happening up there in the cosmos. So, how does this celestial ballet of magnetic fields affect us here on Earth? Well, let's dive in. The Sun and Moon's magnetic fields interacting during an eclipse can lead to some quite remarkable phenomena. For instance, you might be surprised to learn that animal behavior can change significantly during an eclipse. Birds, for example, often go silent, fooled into thinking night has fallen. Spiders may start dismantling their webs, and cows might start heading back to the barn. It's as if the animal kingdom is putting on a show of its own, reacting to the temporary twilight in fascinating ways. But it's not just the animal world that feels the effects. The combined magnetic fields of the sun and moon during an eclipse can also have an impact on our technology. Radio waves, which are a type of electromagnetic radiation, can be affected by these magnetic shifts. This can result in unusual radio propagation patterns and could potentially cause interference in electronic devices. Now, before you start worrying about your smartphone going haywire during the next eclipse, it's important to note that these effects are usually quite minimal and short-lived. In fact, they often go unnoticed by the average person. However, they are of great interest to scientists who study these celestial events, as they offer unique opportunities to learn more about our universe and its magnetic ballet. So, while the spectacle of an eclipse is undeniably awe-inspiring, the invisible dance of magnetic fields that accompanies it is equally fascinating. It's a reminder that even as we go about our daily lives, we are part of a larger cosmic dance, subject to the forces of the universe in ways we may not always perceive. The next time you witness an eclipse, remember, there's more to it than meets the eye. So we've taken a journey through the magnetic fields of the sun and moon and their interplay during an eclipse. We've learned that the sun, our giant dynamo, generates a powerful magnetic field that extends far beyond its surface. We've also discovered that the moon, despite its faded force, plays a crucial role in this celestial dance. We've delved into the fascinating phenomenon of eclipses, where the sun and moon align perfectly, creating a breathtaking spectacle. Moreover, we've seen how this alignment influences the magnetic fields, triggering unique effects observable only during an eclipse. We've discussed the implications of these magnetic shifts, from the way they disturb our planet's magnetosphere to their potential impacts on our technology. In essence, these magnetic fields and their eclipse-induced fluctuations are yet another testament to the intricate and awe-inspiring mechanisms of our universe. As we continue to unravel the mysteries of our universe, every eclipse brings us a step closer to understanding our place within the cosmic ballet.